Hey there, this video is about exponential parent function. This is a special function because there are two parent functions. The first one that we're going to talk about is a growth. It's y equals 2 to the x power. And if we make a table from -2, -1, 0, 1, 2, 3, 4, 5, 6, probably should have started at -3, but -2 is fine. If we plug in 2 to the -2, something special is happening here. We got to apply our negative exponent rules, and it becomes 1 over 2 squared, which is just 4. So it's 1/4. And if it's -1, it's going to be 1/2. 0, anything to the 0 power is 1. And then 2 to the first power is 2. Squared is 4. Cubed is 8. 16, 32, and 64. And obviously this graph isn't going to be big enough to hold that point, but -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 5, 6, 7, 8. And what you'll see is that this graph is getting really close to here, and it just comes upward. And so when it converges, that's not bad, it's not converges. When it diverges away from x-axis, this is how we know that it is a growth. And whenever I say diverges, it means go away from, okay? And there is a very special thing going on here. Because of that negative exponent, it creates an asymptote at y equals 0. So it has a horizontal asymptote. That's one of the critical parts. At y equals 0. Another thing, the y-intercept. It was at 0, 1. Okay? And that was mainly due because of the 0 exponent rule. Oops, y-intercept 0, 1. And those are primarily the main critical parts that you need to know, but you need to understand it diverges away from the x-axis on the right side of the graph, has a horizontal asymptote at y equals 0, and the y-intercept is 0, 1. The next one we're going to look at is the decay, and that is when your base is 1/2. And because the base is 1/2, so for example, I'm going to start this one, -3, -2, -1, 0, 1, 2, 3, 4, and 5. What ends up happening is you're going to end up getting 1, because 1 to any power is just 1, and you're going to get 2 to the x in the bottom. So it's going to do the same thing, except it's going to do the reciprocal of it. So the fifth is going to become 1 over 32. The fourth will be 1 over 16. The third is 1 over 8. 2 is 1 over 4. 1 is 1 over 2. And then 0 is still 1 because it's still 1 divided by 1. And then -1 becomes 2. -2 becomes 3. And -3 becomes 8. So it looks like the same thing, except 5, 6, 7, 8 is starting up high and it ends up down low. And you get 1/2, 1/4, and so forth. So it's almost really like it is reflected across the y-axis. The thing that causes the decay is the base being between 0 and 1. And the thing that causes the growth is whenever it's greater than 1. This one still has that asymptote, but that 1 up top is still never going to turn into 0. So you still have an asymptote at y equals 0. Your y-intercept is at 0, 1. And so your critical part, your horizontal asymptote, is at y equals 0. And your y-intercept is at 0, 1. In class, we're going to talk about how these things can change and what really takes effect with the transformations. But until now, that concludes the video, and you guys have a wonderful day. Bye-bye.